In this video, I'm going to show you how to run an application in a container, specifically in this container technology named Docker. Let's first understand what is a container. A container is conceptually similar to a virtual machine, which is also known as an hypervisor. Some virtual machine technologies include VirtualBox and VMware. You might have used some of those to have a guest operating system running on a host, a Linux machine on a Windows host, a Windows machine on a Linux host, and so forth. But how containers differ from virtual machines is on several facts. First of all, containers are much more lightweight than virtual machines because it doesn't accompany the kernel or the operating system like virtual machines do. So it also doesn't do hardware virtualizations as virtual machines do. For example, a container doesn't have its own network interfaces, it doesn't have its own hard disk space and so forth, right? So those are not virtualized. So those are all being utilized from the host where the containers are running. So essentially, containers only does application virtualization in terms of isolating the dependencies of applications and so forth, which is a vital requirement these days to package your application and ship it to anyone who wants to run it as a container on a supported container platform. This concept isn't new actually. When Docker came into mainstream, uh, many people thought it's a new concept, but it wasn't a new concept even at that stage. It was always there in the Linux environments. So Docker actually brought this container concept into mainstream. I think that's a fair statement, and it's undoubtedly the mainstream container platform today. So let's dive into Docker and understand some of the vocabularies and terms that you come across using Docker, and let's see how to run an application in Docker. Look at some of the terminologies that you might come across when using Docker. So I wrote a blog post probably some time ago, and I'm going to walk you through this particular blog post even on creating or running this application within the container. So let's skim through this. So in fact, some of these reasons to run a container and the differences between container and virtual machines we already discussed now. So when you start working with Docker, you might come across these terminology. So you might hear people talking about Docker client, Docker server, Docker image, a Docker container, and so forth. So let's understand what is a Docker client. A Docker client is basically a command line tool that you use to control a Docker workflow and communicate with a remote Docker server. So it is the one that you interact with usually in a terminal. So when you installed Docker in your machine, probably you will have both the Docker client and Docker server installed in the same machine. But essentially what you want is a Docker client to interact with a Docker server that may be running in your local machine or somewhere remote. So when you hear Docker client, people refer to the Docker command line tool that you run in your terminal. So Docker server is the server software that runs in a daemon mode, which constitute a container technology, and it will also host all the containers that will be deployed, launched, and shut down at some point using a Docker client in a client machine as well. So Docker server is the implementation of that particular technology. And Docker image is again a common word that you will hear. So it is a layer of file systems and other metadata used to run a Dockerized application. So when we look at something called this Docker file, we'll come to know what do we actually mean by these layers of file system. So when you see an example, you will understand that. So for the moment, think about Docker image as a blueprint of Docker containers. A Docker container is a Linux container that can be spawned using a Docker image. So you can consider it as the runtime of a Docker image where things are actually being run. Okay, so that's a Docker container. So we'll obviously to have to interact with Docker, we need to have Docker installed somewhere. So let's do it in the local machine first to start with. So to get Docker, you can use this link and you will be taken into this page when you want to install Docker. So as you can see, you can we have something called Docker Desktop. So Docker Desktop can be installed for Mac, Windows, or for Linux depending on your operating system. So I'm running a Mac here, so I can download this and install. So installation is pretty easy, and I'm not going to walk you through that. However, also keep a close eye on this particular window, update Docker Desktop terms, commercial use of Docker Desktop in large enterprises, which means more than 250 employees or more than 10 million USD in annual revenue, now requires a paid subscription. So that means if you're going to run this Docker Desktop for Mac or whatever the other, I think this is just for Mac, it's showing up. So you just have to see for Windows and Linux when you do it. I think for Linux it's not, but have a look if you're running it on the Linux as well. And your machine is a machine given to you by an enterprise where there are more than 250 employees, or that particular enterprise is having more than 10 million USD in revenue. You need to pay for a subscription to use it. Otherwise you can just download and use it, but I'm not going to do that because I'm going to show you an alternative to do that. So but whatever that we're going to follow through this video is not going to change based on whether you are installing Docker Desktop for Mac or the other one that I'm going to show you. So there is also something called a Rancher Desktop, something similar to Docker Desktop. So remember that the technology that drives Docker and container concept is not just for Docker. And in fact, Rancher Desktop can support Docker, and it provides a Docker API, CLI, and so forth, so that you can use Docker just as if you were using Docker Desktop, right? So it runs a backend that's an open source Docker version. It has modified it and given a nice interface for users to interact with. So you can also download Rancher Desktop for Mac depending on your infrastructure, or for Windows or Linux. This is completely free of charge, and there is no conditions like Docker Desktop in Rancher Desktop. So I have already done it for Mac because I run an Intel, so I have installed it. So once you have installed it, you will have something like this, a window shown up. So in fact, Rancher also ships another technology called container orchestration, particularly a particular orchestration engine called Kubernetes. We are not going to look at Kubernetes in this video. We are just going to look at Docker. So if you have Docker installed, Rancher Desktop installed, you should now have Docker available in your command line to interact with. For example, you should be able to look at Docker version, and it should bring and show you some details about Docker version and API version, and the implementation details of your Docker server and the client here. So the client information here and the server information here. So once you see that thing, you are sure that Docker is being installed and you have access to Docker client and the Docker server. And you can also get further information. I'm not going to drill down into the details of that. You can use the Docker info command to get more details about your Docker installation, and it gives you a lot of other details about the client and the server. And in the server, how many containers are running. At the moment there is 0 containers running, but there are 16 containers defined, all are in stop stage, and there are 24 images and so forth. All these details you can drill down into. Docker is installed, and we just verified the Docker version with the Docker version command and the Docker info command. And now let's look at what this Docker file means. A Docker file is something that you define in your machine on how this Docker image should look like. So it is the instruction method that you specify as a user what this Docker image should look like. We told that Docker images are a set of layers of file systems, right? So what each layer of file system should consist of, and what you're going to do with that file system, and any other commands that you need to run in your Docker container, all these will be specified in a Docker file. Right, so Docker file is a place where you will instruct about these things, and let's do that. And so I have for this video demonstration purpose, I have written a small Flask application. In fact, it's not an application, it is an API, so you can call it an application, that's fine. And because my intention is only to show you how to run this within the Docker container, and the approach is same for any other application as well. And you can I'll post this link down here, but you will have to clone these entire samples because I have kept it as a subdirectory, and you can just navigate into that, and then we can work on this. So let's look at the Docker file first. So I'm already in that Flask API directory, which you can clone and cd into. So if I just look at my contents of that particular file, apart from what you see here, the API, Docker file, Docker compose, readme and requirements, I have few other things which you can ignore at the moment, but like if you're a Python person, you might recognize that some of those details are related to running a Python local virtual environment. But at the moment you just need to think about or look at Docker file, APIs directory, readme file maybe, and the requirements .txt file at the moment. So let's look at the Docker file then, and note how it's been spelled out. It's Docker lowercase f in the file command, file name. So let's use vi to open it, and once you open it you will see a few details. So these are what actually constitute the Docker image. So this is the definition of the Docker image, and so each line gives an instruction to Docker. So now the first line says go get the Ubuntu latest version for this particular image. So when I build this image as the next step, what's going to happen is the Docker client is going to go fetch the Ubuntu image and keep it as a image in your local Docker server. And the next line is just an instruction line saying the maintaining is so and so, and then this run command will say, okay, of this particular file system, run enter into that and then run this particular command. So once you have the Ubuntu file Docker image being taken, when it is run in a container, then it will run this additional command apt get update. It's just a Linux Ubuntu update command, nothing special there. And then we also do run or install these other dependencies. Now why I do this is because I'm going to run this Flask application, so I need Python to do that. So I need the Python 3 pip to install some of the requirements that I will be doing later on, and I obviously need Python runtime and other details necessary to have a Python environment ready for my application. So then as the next step, what I do is I copy the entire current directory to a new folder or new directory named /app, and then I cd into that and make it my working directory. And within that working directory, because now I'm talking about inside the container and I'm in that directory, means whatever the content that you saw previously, you'll be there. And from that directory I'll be running pip3 install -r requirements.txt. We'll have a look at this requirements.txt in a short while. So you saw that file already in my local file system, and once that installation goes through, the next step is to go into the API directory. You saw that API directory as well, and within that API directory we are going to run this python 3 api.py file. So that's what this entry point means. Entry point is to say for this particular container what is the command that spawns that. Okay, so the python 3 will be that, and the command that I'm command line argument, if you can think it that way, will be the api.py. So let's then look at this requirements.txt file soon. So if I just go into requirements.txt, it's not a complex file. It just says what are the dependencies of my application. So this is just a Python thing, Python way of telling, you know, what are the requirements that you need to have, or the dependencies you need to have for your application. So for my application I need this Flask, and you can give the version, and because I'm implementing a REST API, I need this additional dependency called Flask RESTful 039 version, and I'm also having Redis. You know, you can have as many dependencies as you want. Whether you are using those dependencies or not is not a big issue in Python. So once you have that, everything is ready. So next thing that we need to do is, now we have the Docker file in my in your local system. Now you need to build that Docker image. So in this blog post also I have described each of these lines and what they do. So we just did that in this video. So let's go build it. So you just can copy this, and you can just go and paste this. I'm not going to run this because I already have built it so that the images are already available. So what this command does is it's going to build the Docker based on the local directory that you are in, and it's going to look at this Docker file and build that image and give it a name called Flask sample app, whatever the name that you want. And this dot command, this dot specifies that you are looking at this Docker file in the current directory. And once you have it, the Docker image should be created. We can have a look at all the images that's there in the Docker server using this command. Let's see. So let's type it in, Docker image ls. Okay, it's gonna show you a lot of details because I'm running this on Rancher desktop, so there are a bunch of Rancher specific images as well. So what you need to focus on is this Flask sample app, which is the one that I'm interested in, which we have downloaded now by building it, and it has downloaded the Ubuntu image as well. And if the image was downloaded before, it will just utilize that, unless you have specified something else like a different version or anything like that. Because now in this case I'm just taking the latest image, so I have had it created 2 months ago. So when you build it again, it won't just download that once again. So that's a good advantageous thing to have, because otherwise you'll be wasting a lot of disk space on taking images for every Docker file that you create in future. So that's a good feature. So now we have that in place, and now let's move on. And now you have the image, and next thing will be to run your container based on that image. So let's run this. So I'm going to copy this command so that so before we go there, we can also quickly have a look at this API py file. I'm not going to explain on what I have done in this particular API because this is not a Flask tutorial. So I recommend you go through this and just look at this last line. So it's just going to say this particular API is going to run on the local machine on port 8082, and there are 4 resources that you see: the products resource, the company resource, and products with an ID resource, and API host resource. So I think in this video we'll be particularly looking at this API products and the related resource there. So I recommend you go through this, and it's also not in the not in a production scale. I haven't handled all the uh, error conditions and everything, so this is just for demonstration purpose. So just I wanted to show you to look at the code that we're going to run. So I'm gonna tell this. So basically we're going to change this port. By default, the Flask will run it on port 5000, but because I have specified is at 8082, so let's run it on 8082. So what exactly is happening in this command? So it says, okay, run a Docker container with this name called Flask app container. Use this Flask sample app image, which you should be having, and use the port mapping 8082 to 8082. So which means from inside the container, if 8082 port will be looked from outside the container using port 8082 as well. So that's exactly what is happening there. So let's run this. So when you run it, you should you'll just see you will not see anything specific there, but now we can see whether the container is running or not using this command docker ps. And as expected, I have something called a container ID, and I have a name of my image. I have the name of my image. The command that I run is python3 api.py, which you saw in the docker file that I showed to you previously. Yeah, and it's on port 8082, and its name is the Flask app container. So yeah, so that's one command that I wanted to show you. And there is another command to show all the containers regardless of its running state. You can have a look at it as docker ps-a, which will show you a bunch of other containers and its statuses and so forth, right? So we have this container called Flask app container, and I have few other containers which will come to you in a while. So let's quickly test out our API which is running on this container. So for that, I'm gonna go here and use my let's say this command to look at all the and remember to change the port as well to 8082 because I'm running on that. As you can see, it just brings back an empty list. So because I don't have any products already created in that, so let's go create one. Yeah, so again I want to change this to 8082. Yeah, let's see what happens. So when I do that thing, I obviously see a response back with some details, and now let's go back and see all the products. You should be seeing one product now, not an empty one in an array. For the to have another product, let's say, so let's make this a little add a new product here. Let's say a commercial class is being added, and I can say keyword is 12. Okay, something like that. And if I get, now you see two products in it. Okay, so and you can also follow along this to do further commands and to see that how things are working there. So the point is I wanted to focus more on Docker, so let's do that. So then you can stop the container. Now the container is running, so which you can see from docker ps command as in here, but now you can also stop the container and using the container name, or you can also use the container ID instead, which is this one. But if you have a good name, I think that's a good way to stop the container as well. So once it is stopped, you can also go to docker ps to see if it's running. It's not now as expected. Go to docker ps-a to see it was exited 8 seconds ago. So that's exactly what you will also see. So let's go into further details. You can also inspect about a Docker container um, whether it is running or not. You can inspect it, that should be fine. But it does make sense when you inspect it when it's running. For further details, you can just you can see what details you find here. As you can see, a lot of details are there here. I recommend you go through it, understand what each of these details say. So it's at the moment it's not running. As you can see, it says false. Let's run it again. Now you don't need to use docker run command. So you did docker stop, you can start it back once again, and the docker container should be up and running. Let's use docker ps to see if it's up and running. Let's go inspect it now. So when you inspect it, you see now the status is running. It's running, status is true. So likewise, there are more details related to Docker, and there are some advanced stuff as well. So this video, my intention is to show you how to run it, but there's no rocket science. This is not rocket science, so you can just go through and understand other stuff as well. And this video will be a good starting point for you to go in depth later on Docker. Okay, so then yeah, so that's there. So let's stop the container once more, and you can also give a container a label. So it's just as the previous one, but now you will have a label. So you give it a name with label with the image, but in this case I have given two labels. I think I already have that container, so I'm not going to run it. So let's first stop this container, and also look at docker ps-a. If you had run that particular command, you will have this particular thing shown up. So why is this important is you can use the docker ps command or the ps command to filter based on those labels. Like this is particularly useful when you have like thousands of Docker containers running in your platform. Then filtering out will be difficult. And for example, in this case, it's only going to bring the particular container with that particular label. So -f stands for filter. So otherwise, it will just bring a whole bunch of other stuff as well. So if I just do an incorrect one, it will not bring anything. Right, so that's the advantage of having a label as well. So we looked at how to stop it and start it back, and let's start it back, and you can also get into the container. Because it's a Linux container, it will be useful for you to see the contents of it, and maybe it might become useful for you when you debug your applications. If that might come handy as well. So let's start the container once again. So let's do that, and then use this. So Flask app container, I'm going to use this command, execute command, and pass in this bash. So then, as you can see, it has changed your prompt as well. Now you are in the app API directory, because our container Docker file, when we specified, we changed the working directory to the app API, so it will be there. So if I just look at ls, you will see that, and you won't have other Linux commands like vi or less. Those commands will not be available, because we just installed Ubuntu and there's nothing else on that. So only the limited information or limited set of tools will be available. I believe cat command should be available. We can have a look. Yeah, it's there. So you can see the particular file as well. So that will become handy when you want to do a lot of debugging. So you can exit out of it, and yeah, so that's one other detail that you need to know. And you can also remove the Docker container as well. Let's try to remove it and see what happens. So I'm gonna remove it, and obviously I'm getting an error message saying stop the container before attempting to remove or force remove. So because my container is running, it's not allowing me to remove the container. So one way that I can do is I can stop it before removing, stop, and then run the previous command. It will remove. Otherwise I can use remove the container using the -f command, this should remove it, and now I don't get the warning. So if I now go and check docker ps, obviously nothing is running. Docker ps -hey, I don't have the Flask app container. I have some other stuff, but not that particular container. So I have removed it. Okay, and also you can remove the image as well. So to remove the image, you can use rmi command for docker. So if I just look at this, docker ls, docker image ls, I should be able to see my image. If you don't want this image anymore, you can remove it. I have one that doesn't have a name, so you can check on removing that. As an example, I can use you can use the id to remove it. So when you do that, it will go away, so you don't see that anymore, right? So that's an example of removing. Yeah, and there's one more thing that I want to cover before we wrap up this video. Is there is this concept of mounting your container. So now when we ran our container, its file system and everything is actually virtualized in a way that when you make certain changes in your local file system, it won't be seen inside the container. So let's see that in work. So docker ps-a, let me run this container with table, not this mounted one, once again, just to show you what I mean. Docker start this container, and let's see if the container is running. Yes, it is running. Okay, so now if I just go and look at this api.py and use I'll do a little change in my local file system. So import API, import time, I uncommented it. So now let's go into our previous docker command that we ran to ex into that. Of course, the container name is no different. Labels. So I just go into that and use the cat command. And let's go into import time. As you can see, it's still commented. It's not uncommented as the file system one, the local file system one. That's because Docker container created a layer on a layer of file system and made it available in the container. So this particular layer is different from the local file system. But there can be situations where you want to have the same view. That's where this mounting concept comes in, and let's go back to that. So let's exit this, and I'm gonna uncomment my previous or make it, I'll comment it back. So to do that, we can use this command docker run with the name container mounted, which I have already done, with this special -v argument, which says on the present working directory, API directory should be mounted to the app API directory of the container. So when you do that thing, both of the local file system and the file system of the container will have the same view. Basically, it will be the same thing actually. So when you make a change within the container, that will be visible in the local file system. If you make a change in the container, it will be visible inside the container. If you do the change in the local file system and so forth, right? So let's do that. So I have already done this command, so you can copy and run it again. Let's run our so let's see, yes, let's stop this because I don't want this anymore. So you can now use the container ID instead of the container name. That is also another way of doing things. And then if you use docker ps, you should not be able to see that again. So let's run this Flask app with containers, container mounted. So I'm going to say docker start this, So, and let's go into our container like we did before, but with this container mounted name. We go into that and then use cat API, and okay, we see it has commented. Let's uncomment it from within the yeah, because I don't have vi. I'll just do it in the local file system, and let's come back and vi API, and I'm gonna uncomment it to see, and maybe this one also. I'll uncomment both of that to see if it's uncommented inside the container. And if I go into that, I expect it to be uncommented now because we did the mounting. Yeah, as you can see, it's uncommented. So this is the advantage of having the container volume mounted to your local file system as well, right? So there are more things to learn in Docker. So you can also follow through this particular blog post. I will share this link in the description section below. You can also tag a particular image, and I'm tagging it with my username that I have with this Docker Hub. You can go to Docker Hub and create an account, and then you tag it there, and then you can log into your Docker Hub from the command line also. And then once you are done, if you think this particular image is useful for others to have a look, you need to have a common remote repository for you to share, or else you will have to share the entire content of your application as well. But in this case, the Flask app, the Docker file depends on your local file system, so you'll have to host it somewhere. It will not be just something that you can use. Of course, that needs to be shared using a repository like GitHub as well. Then you can also push that particular Docker file somewhere. And of course, this particular a blog post also talks about running a database as a container, like the MySQL container. Basically, this one fetches the MySQL container from the Docker Hub, the standard repository, and then you can have your application actually backed by this particular container as well. So when you run this thing, you can say run my container as MySQL, and you can then do other commands as well. So I'll leave you to get more details on those things. There are other commands like docker stats of the container to get certain details about the memory and the CPU and so forth. Okay, so now we just saw how to run an application, or in this case an API in the container. So the process remains the same for any other application. So that's all I need to cover. I was thinking to cover in this particular video. I hope you enjoyed the video. So we'll see you in more posts like this. So take care. Thank you.